Hello everyone. Yesterday we have discussed some questions of trigonometry, and now today we will discuss about values at certain angles and try to find out that how these values came. Okay. So before going further, I would like to correct one thing. In yesterday's lecture, uh, I have done one question, and in the last part, that was little bit mistake from my side. Okay, so I would like to correct it first. So now in question number in question number 10th. Okay, here PR plus QR equal 25, PQ is equal to 5, value of sin P, cos P and tan P. Okay, so I would like to do that question now. First, draw a triangle. Okay, so now this is triangle. Okay, PQ, right angle at Q. This is angle Q, this is P, and this is R. Okay, so PQR is a right angle triangle where PR plus QR equal to 25 and PQ is equals to 5. PQ is equals to 5 centimeter. Okay, solution. Now PR plus QR. PR plus QR is equals to 25 and PQ is equals to 5 centimeter. Okay, right angle at Q. Now in triangle PQR, by Pythagoras theorem, PR square is equals to QR square plus PQ square plus PQ square. Okay, now we have value of PQ, so we can say PQ square is equals to, this will come here, PR square minus QR square. Okay, now we have PQ square is equals to this PR square minus QR square. Okay, now we can apply a formula of A square minus B square, that is A plus B into A minus B. So this will be PR plus QR into PR minus QR. Now PQ, that is 5 square, PR plus QR 25, PR minus Q. Okay, so here it will be 25, this 25 will come here, 25.25 is equals to PR minus QR. Okay, so we can say PR minus QR is equals to 1. So we have two equations. This is equation number 1. Suppose this is equation number. Okay, so add equation 1 and 2. Why we add? Because here QR is positive and here QR is negative. So if we add, then it will cancel out. QR will cancel out each other and we get the value of PR. So PR plus QR is equals to 25, PR minus QR is equals to 1. Add, so here QR will cancel out each other, so 2 PR is equals to 26 and PR is equals to 13. PR is equals to 13. So if we put this PR in equation number second, put the value of PR in equation second. So here PR is 13 minus QR is equals to 1. So if we shift QR here, so 13 minus 1 is equals to QR. QR is equals to 12. Okay, now we have PR is equals to 13, PR is equals to 13 and QR is equals to 12. Okay, so now we have all three sides. We can easily find sin P, cos P and tan P. And the next question, state whether the following are true or false, justify your answer. The value of 10a is always less than 1. The value of 10a is always less than 1. Is it true or false? It will always less than 1 or not. Now we know 10a is equals to perpendicular upon base. Okay, so meaning 10a less than 1 means perpendicular is less than base. Is it true? Might be or might not be. Okay, so this statement is the value of this always less than 1 is wrong, because it can be perpendicular can be greater than base. Okay, next sec a is equal to 12 upon 5 for same angle a, for some angle a. Is it possible? What is sec a? Sec a, hypotenuse upon base. Is it possible? Yes, it could possible, because hypotenuse is longest side and base and perpendicular are smaller side. Okay, similarly if we see cos a is abbreviation used for cosecant of angle a. Is it true? Cosecant of angle a. Is it cosecant? No, it is cosine of angle a. Now cot a is product of cot and a. Wrong, because cot a is cot of angle a. Similarly sin theta is equal to 4 upon 3 for angle theta. Sin theta is perpendicular upon hypotenuse. As hypotenuse is the longest side of a triangle, so it could not possible. Okay, now we have done whole exercise. We have done whole exercise. Okay, you can write it down. Take a screenshot. Now moving forward, we will find some values of trigonometric ratio at different angles. Okay, now first of all draw a right angle triangle. Okay, so here we draw right angle triangle. Now suppose this is P Q R right angle triangle at P. Okay, now if this side, what is this side for angle Q? This side is perpendicular, this side is base, and this side is hypotenuse. For this angle, this is perpendicular, this is base. Okay, so if we decrease the angle, suppose here or one line which coincide over here. So what we are saying, when we decrease angle, at one case, this angle, suppose this is angle theta, this angle theta is equals to 0. So what is happening in that case? Hypotenuse is lying on base. Hypotenuse is lying on base. That is, both hypotenuse and base are equal, and in that condition, perpendicular is almost equal to 0. Perpendicular is almost equal to 0. Now we know that sine, sine theta is equals to perpendicular upon hypotenuse. So sine 0 is equals to perpendicular, here perpendicular is 0, so 0 upon h, that is sine 0 is equals to 0. Similarly, cos of angle theta is equals to base upon hypotenuse. Now cos theta, cos, here not theta, here 0, cos 0 is equals to, now for theta equal to 0, hypotenuse and base are equal, so we can put hypotenuse for base, in place of base we can put hypotenuse. Now cos of 0 is equals to 1, cos of 0 is equals to 1. Okay, similarly we can find different angles, but right now we are doing only for sine and cos. Okay, now here I am drawing one triangle. Okay, so again this in triangle, this is P, Q and R. We are considering this angle as theta, so it will be perpendicular, it will be base, it will be hypotenuse. Now suppose we increase the value of theta, we increase the value of theta. How will we increase the value of theta? We will go near this angle. At one condition, this side will be on this. So this will be perpendicular, and this will be also base. This side will be perpendicular or hypotenuse. So we are seeing the angle theta. What is angle? Angle theta is here 90 degree. How it is 90 degree? Because at one condition this line gets straight line, and it will make this is base, it will make 90 degree angle. So then theta is equals to, we can see theta equal to 90 degree. Okay. Now when theta is equals to 90 degree, when theta is 90 degree, what is happening here? Now base is almost 0 and perpendicular is equal to hypotenuse. Base is almost 0 and perpendicular is equal to hypotenuse. Okay, so now again sine theta that is perpendicular upon hypotenuse. What is sine? We are dealing with sine 90. What is perpendicular and hypotenuse are equal? Then it will be perpendicular upon perpendicular. So we can say sine 90 is equals to 1. Sine 90 is equals to 1. Similarly, cos of theta is equals to base upon hypotenuse. For 90 degree, base is almost 0. So we can say cos 90 is 0. So we have find the values of sine 90 and cos 90 and sine 0 and cos 0. Okay. I hope you understand how these values came. Okay. Because we oftenly remember the values, but we don't know how these values came. Okay, so I have explained how sine 0 is 0 and how cos 0 is 1, how sine 90 is equals to 1, and how the value of cos 90 gives 1. Okay, now we will do it for other values. We will do it for other values. Okay, suppose, let me clear it. Suppose again we considered a triangle. We considered a triangle. Okay, this is triangle PQR. Now in that triangle, suppose PQ is equals to PR. This is 90. Now when PQ is and PR are equal, then these two angles will be equal, and these two angles will be equals to 45, 45. Because this is 90, angle sum property. Sum of all three angles of triangle is 180. And if two angles are equal and their sum is 90, then both will be 45, 45. Okay. So now, if we consider this angle, this has theta. So here, theta is equals to 45. So for that, it is perpendicular, it is base, it is hypotenuse. So we can say sine 45, that is for this angle 45, is equals to sine 45 is equals to perpendicular, that is PR upon base, that is PQ. Both PR and PQ are equal. Both PR and PQ are equal. Perpendicular upon hypotenuse. Sorry. My mistake. My bad. Now for sine 45, perpendicular upon hypotenuse. For sine 45, so it will be for 45 degree perpendicular is PR and hypotenuse is what? RQ. So now we don't have any relation between PR and RQ. First we need to find relation between PR and RQ. Suppose we consider this as side A and this is also side A. Okay. So if we apply Pythagoras theorem, so A square plus A square is equal to this square, and if A square and A square we add A square, it will be 2A square. So if that square came in that side, so this side will be root 2A, root 2A. So here PR is equals to perpendicular, that is A, and it will be root 2A. So A will cancel out each other. So we can say sine 45 is equals to 1 upon root 2. Similarly, cos 45. Cos 45. For cos 45 again, base upon hypotenuse. Cos 45 base is again A upon hypotenuse is root 2 A will cancel out. So cos 45 is equals to 1 upon root. So we have seen that sin 45 and cos 45 have same value, which is equal to 1 upon root 2. Okay. Now move forward. Okay. So for next values we can draw an okay. So this is an equilateral triangle. Okay. And suppose we draw suppose this is equilateral triangle. A, B, C is an equilateral triangle. We know that in equilateral triangle all sides are equal. This is A and A. Okay, and all angles are equal. That is 60, 60, and this whole angle is 60 degree. Okay. Now suppose this is D. Suppose AD is altitude. AD is altitude. As we know, in equilateral triangle, altitude, median, and angle bisector coincide on the same line. So it will be altitude as well as angle bisector as well as median. So if this is median, this side will be A by 2, and this side will also A by 2. This angle, whole angle is 60. So this angle will be 30 degree. Okay. So if we see in triangle ABD, in triangle ABD, for this angle, angle B, sine of angle B is equals to perpendicular upon hypotenuse. What is perpendicular for this? AD. What is hypotenuse? That is AB. AB. Now, what is the value of B? B is, what is angle B? Sine 60. Now, what is AD? We don't have any relation between AB and AD. First, we need to find relation. Now, this is A. This is A by 4. If we apply Pythagoras theorem, this will be A square is equals to A square by 4 plus AD square. Okay, and if we solve, we will get AD square is equals to 3 A square upon 4, and AD is equals to root 3 upon 2A. Applying by it will come after applying Pythagoras theorem. So you can do and solve this. Okay, I have done it in shortcut. Now where AD is equals to root 3 upon 2A, and this AB is also A. So here sine of 60 is equals to, this A and A will cancel out each other, root 3 upon 2. So we have find the value of sine 30, sine 60. Similarly, cos 60, cos 60. For cos 60, for 60, that is base. Base is BD, A upon 2, and what is hypotenuse? That is A. So cos 60 will be 1 upon, cos 60 will be 1 upon 2. Okay. Now, if we see this angle BAB, sine of angle BAD, that is 30. Sine 30 again perpendicular upon hypotenuse. What is perpendicular? For this angle, perpendicular is BD. And what is the value of BD? That is A by 2. Hypotenuse A. So it will be equal to sine 30 is equals to 1 upon 2. Okay. If we solve for cos 30, cos 30 base upon hypotenuse, that is cos 30. For 30, base is 80, which is root 3 by 2 A upon A. A and A will cancel out each other. So cos 30 is equals to root 3 by 2. Root 3 by 2. Okay. So we have find values at different angles. Okay. So let revise all. We get values of sine and cos. Sine at angle 0, at angle 30, at angle 45, at angle 60, or at angle 90. For 0, we get sine 0 cos 1. For 30, 1 upon 2 root 3 upon 2. For 45 same value, 1 upon 2, 1 upon 2. For 60 it is root 3 upon 2, it is 1 upon 2. For 90 it is 1, for 90 it is 0. Okay, so we have find the values of sin theta and cos theta at different angle. Okay, so in the next class we will discuss and we will find some more values. Okay, till then be with us. Thank you so much.